So in this lesson, we're going to look at about three problems where we're going to solve rational equations. And the directions will say clear fractions using the least common denominator. So make sure you understand when you're doing the homework that you know what I mean by this. All right, so let's look at some examples that uses this idea. So let's look at number one. Number one, we have 8 divided by x minus 7 is equal to a negative 2 divided by x plus 4. Okay, now, first thing you got to do before you can find the least common denominator is to make sure that all of your denominators are factored. Well, if you notice that x minus 7, x plus 4, those are linear factors, and the GCF in both cases is 1. So in terms of factoring, there's not anything I can do. So once you get to that point though, once you factor, once you got to the point where everything is completely factored, then you find the LCD. So your LCD must include every factor you see. So I see an x minus 7, I have to use it. Notice the parentheses. I see an x plus 4, I have to use. Notice the parentheses. So your least common denominator is going to be a product of all of these factors. Okay? Now, one thing you gotta remember is from your lessons is that when solving rational equations, notice that the denominators have variables in them. So you got to be careful because you could introduce, if you recall from the lessons, the words extraneous solutions, extraneous solutions. So those are false solutions. So those are solutions that are not actually solutions to this equation. And one of the things that helped you with that was to determine what makes this denominator zero. Because remember, you can't divide by zero. Dividing by zero is undefined. So at that point, if you recall, we found restrictions. So let's go ahead and find those restrictions. And basically, you're asking yourself, what can't x be? So basically, you just look at your denominator. You don't care what the numerator is. It's your denominator that cannot be zero. So your numerator can be any real number. Your denominator cannot be zero. So if you look at the um, at the denominator here, x minus 7, most students, since that's a linear factor, most students can easily look at these and determine what value of x makes this 0, what values of x makes this 0. But if you need to write it out, you write it out. So for example, x minus 7 equals 0. You solve that equation. So x equals 7. You add 7 to both sides, right? And so one of my restrictions is that x cannot equal 7. Now you have another one because those are different. So you do the other one. So x plus 4 equals 0. What's going to make x plus 4 equal to 0? Well, when x is negative 4. So there's your other restriction. Okay? All right, now once you find your least common denominator, the next step is to multiply both sides by the least common denominator. That is the next step. When you're asked to do it this way, that is your next step. So notice though that on each side there's only one fraction. So I'm not going to put any of those in parentheses. I'm not going to do any of that like we did in a previous lessons. So I'm just going to go ahead and multiply both sides by the least common denominator. So I'm going to say x minus 7 times x plus 4 times the first fraction, 8 divided by x minus 7 equals, and then the LCD, x minus 7 times x plus 4 times the second. Okay? Now at that point, that's where when we clear the fractions, these factors down here will be factors of 1 now. So in other words, this x minus 7 better reduce with one of the factors up here, and it does because remember that and that are part of your LCD. So those divide out. So x minus 7's divide out. Make sure you put ones in their place though, because you're left with factors of 1. So now we have 1 times x plus 4 times 8, because 8 over divided by 1 is 8. So I get 8 times x plus 4 equal. Over here, the x plus 4's divide out. You must show that you're reducing these. So you must show this. So you have x minus 7 times 1 times a negative 2 is a negative 2 times x minus 7. All right, now notice I went from a rational equation to a linear equation. So we're going to go ahead and distribute. And so when I do that, I get 8x plus 32 equals, and over here I get negative 2x plus 14. All right, now bring all the variables one side, constants to the other. So I'm going to go ahead and add 2x to both sides. And they combine like terms. I get 10x plus 32 equals, and then notice this is 0, and you're left with 14. Subtract 32 from both sides. Combine like terms. I get 10x equal, and that's going to be a negative 18. And then divide both sides by 10. And then reduce, I get x, 10 divided by 10 is 1, 1 times x is x, so I get x to be negative 18 tenths, which equals a negative 9 fifths. So that's your solution. And notice though, before I circle it, I better make sure it's not one of those restrictions, and it's not. So this is not an extraneous solution because it's not one of my restrictions. So all of these equations are equivalent, and the solution to all of these, even the original, is negative 9 fifths. All right, so that's number one. Let's look at number two. So number two, let's suppose we had this equation. We had 11 divided by x squared plus x plus 9 divided by x equals 4 divided by x plus 1. All right, so again, the first thing you have to do is factor your denominators. So notice, though, that this is a monomial factor, so there's not anything I can do with that one. This is a linear factor where the GCF is 1, so I can't do anything with that. But here, the GCF here is x. I can factor out an x. I get x times x plus 1. Okay? So I'm going to go ahead and rewrite this like this now. So I'm going to say 11 divided by x times x plus 1 plus 9 divided by x equals 4 divided by x plus 1. Okay? So make sure you rewrite your denominators in factored form, because that's going to be important when you multiply by the LCD. So now the LCD, remember, has to include every factor you see. So if we start with the first denominator, I have a factor of x, I have to use it. I have a factor of x plus 1, I have to use it. See how that looks? I have a factor of x, I already have it. I have a factor of x plus 1, I already have it. So there's your LCD. And leave it factored. Don't multiply it out. Some of you want to go ahead and multiply this out. Don't do that. Leave it in factored form. I'm not sure why you want to spend the time doing that when it becomes more complicated. You could easily mess up with your terms. So leave it in factored form. Now the next thing you got to do is find the restrictions. So your restrictions. So if you look at all your factors, remember it's your factors you're looking at. So it's your factors. So if you look at your factors, my first factor is x. I said that equals 0, and I solve for x. So it's already solved for x. So your restriction, x cannot equal 0. The next one, x plus 1. Said that equal to 0. Where's x plus 1 equal to 0? Well, when x is negative 1. So there's your other one. Here you've already taken care of that. So that's 0 when x is 0. And this is 0 when x is negative 1, because negative 1 plus 1 is 0. Same thing here, right? When x is 0, 0 times 0 plus 1 is 1. So 0 times 1 is 0. When x is negative 1, negative 1. And here, this factor, negative 1 plus 1 is 0. So negative 1 times 0 is 0. So those are your two restrictions. All right, now, the next step is to multiply both sides by the LCD to clear those fractions. Notice, though, there are two fractions on this side, so I'm going to put that in parentheses. So I'm going to say x times x plus 1 times this left side, 11 over x times x plus 1 plus 9 over x equal. Now, since that's just one fraction here, I'm not going to put that in parentheses. I'm just going to say x times x plus 1 times 4 divided by x plus 1, just like that. Okay? So all I did was I multiplied the left side by the LCD and the right side by the LCD. Now, be careful. You've got to distribute here. Okay, don't reduce because you're going to mess up. You distribute first. So you get x times x plus 1 times the first fraction plus x times x plus 1 times the second fraction equals, I'm just going ahead and rewrite this over, x times x plus 1 times the fraction on the right hand side. So basically what you're doing, and that's the idea, remember, is to multiply each of these rational expressions by the LCD, and that's what I did. So notice this is here, it's being multiplied by the LCD. This is here, it's being multiplied by the LCD. This is here, it's being multiplied by the LCD. At this point now, when you get to that point, then every denominator should now be a factor of 1 when you reduce. So notice this is the same as this. So those divide out. So you get 1 times 11 is 11. Plus, in this case, x here, you see that the only factor you see here is x. So you better reduce it with this x. And so you got to be careful. You get 1 times x plus 1 times 9. So this really becomes 9 times x plus 1, just like that. Okay? Equal, here, the x plus 1's divide out. So you have x times 1 times 4, which is 4x. So that's where I'm at. Now you got to be careful. Some students, they're going to say 11 plus 9 is 20 and then distribute the 20. That's not true. That's a plus sign. That's not true. You got to multiply before you add. So you have to distribute first. So that's 11 plus 9x, and then 9 times 1 is 9, equal 4x. Now combining like terms, 11 plus 9 is, what's that, 20? So I get 20 plus 9x equal 4x. So notice I have a linear equation. So I went from a rational equation to a linear equation. I'm going to go ahead and subtract 9x from both sides. And so combine like terms, I get 20 equal a negative 5x. Divide both sides by negative 5 and reduce. Negative 5 divided by negative 5 is 1. 1 times x is x. I get x to be a negative 4. Before you say that's the solution, make sure that's not one of your restrictions, and it's not. So that's your solution. So if you did all this work correctly, this should be it. Okay? All right, let's look at number 3. So let's do one more. So number 3, you have, let's see if I can find the problem real quick. So here's the problem. You have 8 divided by x minus 3 minus 4 equal 5 divided by 2x minus 6. Okay? All right, so again, notice you have this rational equation. You have variables in the denominator. So you have 3 rational expressions. You have this one, you have this one, you have this one. Here, though, remember that's the same thing as saying subtract 4 divided by 1. So just keep that in mind. The only one I can factor is this one. So let's go ahead and factor out a 2, and this is what I have. Now we're going to go ahead and rewrite this over using factored form. So I get 8 divided by x minus 3 minus 4 equal 5 divided by 2 times x minus 3. Okay? So now we can find the least common denominator. Your least common denominators include every factor that you see in your denominator. So I see an x minus 2, I have to use it. X minus 3 rather, I have to use it. This is a 1, so 1 is a factor of every expression. Here though, there's a 2, so I need to put that 2 there. This is x minus 3, I already have that factor. So there's your LCD. And again, don't distribute, leave it in factored form. Leave it in factored form. So it's 2 times x minus 3. Once you get to that point, we've got to find the restrictions. So remember, your restrictions, all you got to do is go to your factors in your denominator and see what makes the 0. So if you notice x minus 3, so where's x minus 3 equals 0? Well, when x is 3, right? Because 3 minus 3 is 0, and 8 divided by 0 is undefined. Here, that's a 1, so there are no variables there in the denominator. So your denominator is always going to be 1. It's never going to be undefined. Here, your 2 factors are 2 and x minus 3, but 2 is a number. So the only thing you need to look at is this. What makes this 0? So when I say 2 is a number, I mean 2 is not 0. So it's never going to be 0. So this is going to be 0 when x is 3, which I already have. So there's only one restriction here, and that's this one. So once you do that, you're going to take your LCD and multiply both sides by it. So notice that on this side you have 2 expressions, 2 rational expressions. So I'm going to put that in parentheses. I'm going to say 2 times x minus 3 times 8 divided by x minus 3 minus 4, just like that. Okay? Equal, and then your LCD times this. So 2 times x minus 3 times 5 divided by 2 times x minus 3. Okay? The next step, remember, is to distribute here. So you get 2 times x minus 3 times 8 divided by x minus 3. Now be careful with this. A lot of students get caught up with this because they don't see a fraction. But remember, this has to be multiplied by this as well. So write it like this first. So say minus 4 times the LCD. So here's my LCD, like this. Leave it like this for right now so you don't mess up. Equal, I'm just going to rewrite this over. 2 times x minus 3 times 5 divided by 2 times x minus 3. All right, now over here, remember the whole point of multiplying by the LCD is to get these denominators to be ones, to be factors of ones, and now we do. So the x minus 3's divide out. Now notice what I have. 2 times 1 times 8 is 16. Okay, now be careful here. Remember, if you read this is forget about the subtraction right here. If you read this says 4 times 2 times x minus 3. So let's go ahead and multiply 4 and 2 first. I'm going to get minus 8 times x minus 3. See, that's this right here, right? Okay. Equal, and then these divide out, so you're left with 1 times 5 is 5. So notice I went from a rational equation to a linear. Now at this point, you got to distribute first. Don't say 16 minus 8 is 8. You have to distribute first. Because remember, in terms of the order of operations, multiplication, you do multiplication before subtraction. So I get 16. I'm going to distribute the negative 8. Negative 8 times x is a negative 8x. Negative 8 times a negative 3 is a positive 24, equal 5. Combine like terms, 16 and 24, that looks like that's 40. So I get negative 8x plus 40 is equal to 5. Subtract 40 from both sides. Combine like terms, I get negative 8x equals a negative 35. Divide both sides by negative 8. And then reduce. Negative 8 divided by negative 8 is 1. 1 times x is x. A negative divided by negative is a positive. And I can't reduce that any further, so I'm just going to write as 35 divided by 8. Now notice 30. Now if you want to write this as a mixed number, you can. Don't write as a decimal, because a lot of you want to write things as decimals, and when it doesn't terminate, you approximate, which is no longer an exact answer. So leave it as a improper fraction or a mixed number. So 8 divided by 35, or 8 divided into 35, or 35 divided by 8 will be 4 with remainder of 3. So you get 4. So you get 4 and 3/8. So either one of those is fine. Most students will leave it like this. But before you do that, though, make sure that's not a restriction, and it's not. So you're good. So that's your solution. Okay? So that's what the work should look like. So make sure before you do this worksheet that involves solving rational equations using the LCD and clearing the fractions, that you look at this first. So because you want all your points. Okay, so that's the end of the 3 problems.